Hello, this is the second video of the Calculus 1 series on improper integrals for OCR Pure Core Further Mathematics, and it looks at integrals with infinite limits that are divergent. In the previous video we looked at the integral of f of x equals 1 over x squared, which proved to be convergent for an infinite limit. Here we're looking at the function of 1 over x. Again, although 1 over x tends to 0 as x tends to infinity, the area has infinite length. So we need to look at a limit, and as before it is difficult to tell whether or not there is a finite numerical answer. As we did in the previous video, we replace the difficult or problem value limit of infinity by a variable a, and look at what happens in the limit as a tends to infinity. Here, 1 over x integrates to the natural log of x. Which leads us to looking at, as a tends to infinity, the natural log of a minus the natural log of 2. However, as ln a does not converge to a numerical answer as a tends to infinity, this is not defined. Hence, this integral is divergent, is not defined in the limit, and therefore has no numerical value. So, comparing the two functions, f of x equals 1 over x squared and f of x equals 1 over x, we can see the graphs of the functions look similar, yet one is convergent and the other is divergent. It is very difficult to determine this until you look at what happens in the limit. Here we have a dynamic GeoGebra which shows what happens for the area under 1 over x squared as we move from the lower limit of 2 towards infinity. So moving to point B, which is the upper limit for the integral, as you can see it is increasing but hopefully you will accept the fact that that is moving towards a half but will be limited by half. In comparison, let's look at the area under y equals 1 over x. And we can see that it steadily increases the area under the curve. And there seems to be no sign of it approaching a limit. Again, we'll look at a quick summary of the technique. We've replaced the problem limit with a variable, called it a, and looked at what happens in the limit as the variable tends to this problem value. So if there is a numerical answer, the integral with infinite limit is convergent. If not, as in the case of f of x equals 1 over x, then it is divergent. In the next video, we will look at integrals with the function undefined at a limit.